Good day, grade 9 science students. Today what we're learning about is something known as density. Now density is a type of physical property. Remember that we can have chemical properties, we can have physical properties. Physical properties are specific things that we describe or observe about a substance that do not change the substance itself. So oil has a different density than water because they're different substances. You can see above me, look up, just directly above me, you can see that I have, oops, sorry I changed my slide there, directly above me, you can see you have several different substances. Let's watch a video and let's see why, or see if you can determine why certain things happen. And it has to do with something called density.
So we're talking about density, and as we measure density, it's just the amount of stuff kind of crammed into one place. And by technical definition, you see this little graduated cylinder that's here? It's the weight of, for example, the density of water is the weight of 1 gram, or the weight of 1 milliliter of water.
What is density? Well, it's the term that's used to describe the relationship between the mass, or how heavy something is, and the volume that it takes up, the space it takes up. And density is determined by dividing the mass by the volume of a substance. Now we measure mass in grams and we measure volume in milliliters, which is the same as saying a cubic centimeter. Imagine you had a cube that was 1 centimeter, each side was 1 centimeter, and that would be 1 milliliter. So density is when a piece of matter has a large mass and a small volume, that means it's very heavy, it's very dense, and so therefore it's going to sink. When a piece of matter has a small mass compared to a large volume, that means it's very light per its volume, and so therefore it's going to float.
That weighs a gram, yeah. So the density of water being 1, that's really, really important for us to know. We have to pick things that are either more dense or less dense. So I picked a couple things for you. First of all, household Karo syrup. The light stuff seems to work pretty well, and you can color it nicely. So I colored this one blue for you. Oh. So go ahead and fill up the container here, about a quarter full, maybe a third full, and keep it off the edges. Perfect.
Oh, sorry, keep it off the edges.
No, it's fine. It's fine. Perfect. Oh, that's perfect right there. That's great. Yeah.
Oh shoot!
It's perfect. And now we need white because we want to do red, white, and blue.
Okay.
So I just took water and added some of this coffee mate to it. So that
look at the white
just going to slowly kind of pour it in there and see what happens there. So you might get a little bit there. So a nice little slow. Yeah, there you go. Keep on going. Keep on going. Looking
I might
good.
even succeed in washing the side of the
You
glass.
are doing great. So there's a red, there's a white, and a blue, and of course the red has to sit on top of that. So you can go just a little bit more. Perfect. All right. Now the red is lamp oil. This is what lamp oil looks like. So if you have a concern, you're not going to give the kids just lamp oil.
Have some of those lamps with the wicks in them, and you put lamp
exactly.
oil in.
Right. So there's your lamp oil. So now just do your lamp oil right there. You ready? So
slowly.
Lamp oil right there. Good job.
Right down the middle of them.
Right down, right on the top is perfect. Is that fun? Look at how it's just going to sit there and it's going to layer. So that Karo syrup seems to be part of the magic there. So you can layer that in there, and so now you get a clear red, white, and blue.
So the video really shows why some things sink and some things float. And it has to do with density. Well, how do we calculate density? In science, we calculate density using the formula. Density equals mass divided by volume. Now, you can rearrange this algebraically, and I'm going to show you how to do this, or you can use this triangle. Cover up what you want to find. And for example, if I covered up density, density would equal mass divided by volume. Volume would equal mass divided by density. Now, we'll learn how to use that in class a little bit more. But density is a value, and the most important value you have to remember for density is that water is 1 gram for 1 milliliter. To measure density in industry, for example, in the food and beverage industry, for example, they use something known as a hydrometer. Now, hydrometer is just simply an object that you place inside a liquid, and whether it sinks or floats, it determines how dense it is. It has some markings on there, and it tells you what the density is. So if a liquid is much denser than the object, most of the object will be above the surface of the liquid. For example, if you take a cork and you put it in water, most of the cork will be above the water. Therefore, it's less dense. If you take an object that is more dense than an object, than a liquid, it's going to sink. For example, If you take a piece of metal and you put it in water, it's going to be mostly underwater because it's more dense. A hydrometer uses this to quickly tell what the density of an object is. So, to find density, we have to know the mass, which is easy. We can just use a scale in the lab to weigh something. And we need to know the volume. And there's an easy way to know the volume of any object. For example, if I take a pen here and I want to know the volume of this object, all I need to do is take my cup here and I fill it up with water right to the top, put the pen inside the cup full of water, and the amount of water that comes out of the cup is exactly equal to the same volume as that pen. This is known as the displacement method. You can write down my note what I've written in this PowerPoint here. But this is a way that we can find the volume of any substance. And once we know the volume, we can take it with its mass and we can find the density. So each substance on the periodic table has a slightly different density. And if you look on your periodic table that I gave you, or actually the one that's in our classroom, if it's a red substance on the periodic table, generally it's a gas at room temperature. If it's black, it is a solid, and if it's blue, it's a liquid. But there's also density values on each one of those elements on the periodic table, which we're going to talk more about it. But again, density is a unique physical property for unique substances. That's the end of today's video. We're going to learn how to use that equation tomorrow. I'm going to show you the rest of the video from the newscast here, and you're welcome to watch it as well if you're interested. Have a good day and see you tomorrow.
And 3 are not hard. I mean, it's pretty easy to do 3. And
Three
so
is child's play if I can do it.
7.
Yes,
all right?
7.
So take a look at this. On the very, very bottom of this one here, we started honey. All right.
Honey?
So honey, and I had to do it kind of slowly. So Karo syrup is the next thing.
Okay.
And then we have some Dawn dish soap. So there's, and now we're going to try to just layer in some water. So you slowly have to try to pour the water in here. And so that kind of goes in and you get a layer of the water. Now you want to go as slow as you can. So you can see for TV, we're going to go just a little bit faster.
Sure.
But we're going to try to get that in there. And then our final layers. So oil will sit on top of that. And that's kind of where you wrap the whole thing up normally. And most people would wrap up oil at that point.
But not us.
But of course not, because why would we just do that, right? Why would we do that? So we need a little bit of oil that will go for the next one. And that one will be a little bit easier. So here's this. Here's a little bit of that oil. So we'll see if the oil kind of sits in there. So again, the object, of course, is about 7 layers. If you can do 7 layers, that's a pretty amazing thing. So there's that piece. And you can see the final one. So we're going to do, believe it or not, next is going to be rubbing alcohol. So you can push rubbing alcohol and set it on the top. And you can color rubbing alcohol. So you can see our water in there. And now we're just going to use the rubbing alcohol. And I made this purple. So a little bit of food coloring will give us this. And
so rubbing alcohol is super, super light, or not as dense.
Not as dense, right? Not as dense. So not as dense as the vegetable oil. So you kind of see what that is there.
This is
and that's kind of layers
cool.
out. And if you move the final little column slowly into place, you can kind of see what this whole thing is going to look like.
I should
you can move it. No, it's okay. You can move it. Just
I'm scared to death.
No, that's okay. You can just move that last one there.
Right,
you can see why it's a slow process, but eventually it starts to layer out there. It looks pretty good. And take a look at what happens when you really you move it in place, and we put a little bit of that paper behind it. You get a chance to see what that looks like. And,
are you ready for this?
Oh, look at this.
Oh, this is, and then
nice.
What happens is it'll graduate up. But look at the finished cylinder,
and
nice? I'll put this paper behind it,
so
as I was instructed by.
See, there's our 7 layers right there. Dun, da, da, da.
Look at that. I mean,
so we go from red, white, and blue to all of that. So Karo syrup, of course, being extremely dense, and our lamp oil on the top not as dense at all. So we get all 7 layers sitting there, and water sitting in the very middle.
That is just the coolest experiment. That is so much fun. He was